Alrighty, ladies and gentlemen, we have ourselves 10.8, the Power Theorems. I got the power! Yes, that's a good song. Okay? Anyways, let us begin. Alright, it looks like we got ourselves a messed up import once again. We've got some issues with the formulas. Anyways, these formulas are in no way a help without the diagrams, so make sure you draw the diagrams with them. What it's saying is that each piece of the chord multiplied together equals the other chord pieces multiplied together. Okay, that's what this one's saying right here. So, portion of the chord times portion of the chord is equal to portion of this chord times the portion of the chord. Okay, cool, awesome. Moving on. With this one here, again, make sure you draw that diagram. All it's saying here is the outer part times the entire thing is equal to the outer part times the entire thing. Okie doke. I like to think about it visually like that rather than remembering a whole formula. Just knowing that the outside times everything equals outside times everything. Okay? The last one that we've got here, I also think about this one like almost exactly like the last theorem. The outside of this one times the whole thing, which is this side of the formula, is equal to the outside times the whole thing. But it's just c squared because the outside and the whole thing are the same thing. All right? Outside times whole thing equals outside times whole thing. Cool. I'm going to continue moving, even though I'm moving kind of quick. You can pause it if you need to write stuff down. Let's do some practice problems. Okie dokie. We've got FH is x plus 3. We've got HB is x plus 1. And I've got AH is 3. And HG is 5. Well, if I take my new theorems, I've got 3 times 5. This is the chord. 3 times 5 is equal to x plus 3 times x plus 5. I wonder if you guys can hear Jenny's collar jingling over here. Jenny, how you doing? You doing all right? She's just napping on the couch here. Alrighty. So we've got 15 is equal to, I'm going to have to FOIL this bad boy, x squared plus 3x plus x plus 3. So I'm going to combine like terms and bring stuff over all at the same time. 0 equals, because I know if it's a quadratic like I have here, I'm going to have to factor. Oh, gosh. I love it. Okay, so I get 4x minus 12 when I subtract the 15 over. Okay, well, what multiplies to negative 12 and adds to 4? Well, that's going to be 6 and negative 2, ladies and gentlemen. Woo-woo! Okay, so I get negative 6. And I get positive 2. Well, when I look back at my original, if I plugged in negative 6, I'd get negative 3 and negative 5, so that ain't going to work. If I plug 2 in, I'm going to get 5 and 3, so 2 does work. I am only, I'm finding HB. Okay, so I do need to plug this in and actually get my answer, which would be 2 plus 1, which is 3. Cool. Awesome. So that is HB in this case. It is a coincidence, guys, that it's 3 and 5, 3 and 5 for this one, okay? It's not always going to be the exact same as the other two segments, okay? Just a coincidence. All right, find BE if AD is 5. We got DC is 4. And I've got CB, the whole thing, is 12. Cool. Alrighty, so I've got, this is the secant, it looks like. So outside part times the whole thing, which is 4 plus 5, is equal to, well, I don't know what the outside part is. I'm trying to find BE. I'll call this guy X. Well, that makes the outside part 12 minus X, right? Okay. So I'm going to have outside part of 12 minus x times the whole thing, which is just 12. So you do have to be kind of careful setting these formulas up because sometimes they look a little bit funky, right? It's, again, the outside part times the whole thing, so 4 times 9. Outside part, 12 minus x, times the whole thing, which is just 12. Some people will put CE as x and do x times 12, but then you have to subtract at the end. So you could have set this up differently. This is how I chose to set it up. So 4 times 9 is 36 is equal to, let's see here. I've got 144 minus 12x Okie doke. So I'm going to have, let's see here, 12x is equal to 108. That sounds about right. Okay. So then I get x is equal to, if I divide out by 12, I get 9. Awesome. Cool. That is just wonderfully, wonderfully fantastic, don't you think? These theorems are indeed quite powerful. Okay. Awesome. All right, we want to find the value of x. Well, this is the tangent secant, or secant tangent, whatever that order it was, formula. So I'm going to have the outside, or the tangent guy, squared is equal to the outside part. That was a dope voice crack. I'm going to leave it in there. Times the whole thing, x plus 5. Cool. Now, on the left-hand side, when I'm squaring this binomial, oh my goodness, if you just distribute it and get x squared plus 4, I will be very upset with you. I got to think of it as like x plus 2 times x plus 2. Okay? And then we FOIL it, so we get plus 4x plus 4 is equal to x squared plus 5x. All right, and then I will go ahead and I'm going to work on that plus sign there, whatever. And I'm going to solve. Well, my what's nice thing going on here is boom, boom. Those guys are gone. Don't have to deal with the quadratic, so that is dope. And I'm going to subtract the 4x over, so I get 4 equals, well, 5x minus 4x is just x. America. Cool, and it's only asking us to find the value of x, so we don't even have to find another length. You do want to make sure the answer makes sense in the problem. Those would all give me positive lengths, so it makes sense. Cool. Moving on. It makes sense like a Costco membership makes sense because it's just a fantastic place. Okay, moving on. All right, let's do another example here. We got AE is 8. I'm going to change colors here. I think I'm going to go with a little lovely purple. Okay. So this is 8. We got EC is 4, quattro, and we got BD is 18. Okay, find ED. I'll go ahead and call ED X, which makes BE 18 minus X. Cool. Okay, well this looks like the chord. So it's going to be 4 times 8 is equal to X times X, or 18 minus X. Okay. Well, let's get to work, shall we? This is 18x minus x squared. I'm going to bring everything over to the left-hand side so my x squared becomes positive. It's a little bit easier to deal with, don't you think? Oops. Plus 32 equals 0. So I'm going to factor this thing. It'll be x minus 16 and x minus 2. And you, I'm sure, are getting just as fast because you guys are factoring champs. So I get 16 and I get 2. All right. Well, so these are x values. I've assigned ED as x, so what I get for x is my answer. So x equals this and x equals this. Now, do they both work? Let's see here. If I plug 16 in, I get 16 and 2 for my lengths. That's cool. If I plug 2 in, I get 2 and 16 for my lengths. So that's cool. So they technically both work. You might be saying, whoa, dog, what the heck are you talking about? That don't make no sense. I can't have 2 lengths at the same time. Well, they are not at the same time, children. Okay, these are just 2 potential lengths based on the information that is given. So there could be 2 different situations. I like to think of it as this chord could have been over here, right? Making it a whole, like basically reflecting it over, right? A whole different image, but the same type of situation, but on that side, okay? So you can have 2 different solutions, even though it's like one diagram. Don't think of it as a fixed diagram in this kind of situation. Things could be fluid, if you will, okay? Lovely. All right, here we go. Last problem of the day. We got TZ is 6. I've got, that's a terrible 6. That's not really that great either. That's all right. All right, and then we got YZ is 4. And I've got SX is 3 and WX is 1. And I want to figure out what XT is. Okay. Well, can I outright figure out what XT is? No, I cannot. I'll call it X, though. We'll solve for it eventually. For now, I got to figure out something else. Well, I could figure out XY with my given information and then use that to find XT, right? So let's call this guy y. Alrighty. Well, how would I do that? Well, that's my tangent secant. Right? So I'd have 6 squared is equal to outside, which is 4 times the whole thing. 3 plus 4 plus y. Alright, or 7 plus y. So I get 36 is equal to, well, 4 times 7 is 28 plus 4y. Got to distribute it, right? Bring that over, I get 8 is equal to 4y. So y equals 2. Okay. So I'm going to go ahead and erase this guy and write down 2. Now I can use my chord, which would be 3 times 2 is equal to 1 times x. So x equals 6. And there's my final answer. That's xt. I can even write down xt because I'm crazy like that. Cool. Excellent. Wonderful. Now be careful. I think these problems are deceptively easy, much like the in, out, and on angles. But then when you get to a quiz or a test and everything's all together and you got to figure out what to use, it can be kind of tricky. So the practicing with the H-dubs is a solid idea. Alright, here's our homework. Don't really pay attention necessarily to this because obviously these videos are recorded. Therefore, if anything changes as far as dates go, that could potentially change from year to year. Okay. Anyways, do homework things and practice math.